SEAPOWER project aims to promote the collaborative research and development of technologies and solutions for offshore wind power. For that purpose, 9 companies coordinated by SENER joined forces in SEAPOWER to cooperate and look for synergies in the development of new offshore wind solutions. Our motivation for the project was the vision of significant growth in offshore wind, the confidence in the capacity for engineering and fabrication of the past companies, collaborating in the transition to a climate-neutral society, and the compliance with the research and innovation smart specialization strategy of the Basque Country.
SENER, within SEAPOWER, has developed tools, numerical models, and designed a high-power patented floating foundation, which is highly innovative, particularly in terms of its standardization, easy manufacturing, and weight reduction. SEAPOWER has provided SENER the ability to offer the market our own product, while reaching a level of technological maturity of TRL5 as demonstrated by a tank test and ready for further development with a demonstration on a real scale and in sea conditions. Thanks to this project, a new company called High Wind Energy has been created with Nervión Naval Offshore to commercially exploit SENER's results within SEAPOWER.
As you know, floating wind turbines in development today are already for 15 or even 20 megawatts wind turbine. So floater developers like us need to be ready for this. At Nautilus, we are prepared for this larger wind turbine, and in particular through the research project SEAPOWER, we have developed a numerical methodology to assess the natural period of the larger towers that come with these larger wind turbines. And also we have showed that our floater technology gets less dependent on weather and cheaper per megawatt for these larger wind turbines.
The real challenge was to think out of the box in order to design an innovative solution that in some way, from technical and economical point of view, optimize the existing solution of jackets. In that way, our solution with a central node has demonstrated that there was room for optimization, reducing the number of joints between 15 and 30% and the total weight of the structure between 5 and 10% in comparison with the existing solution.
Well, there will be many, but I would like to highlight 2 that in ICEA we consider very relevant. First of all, from a design perspective, we will see new bolting techniques, eventually leading to a reduction in the number of sections per tower, which will make them heavier and longer. Secondly, from a manufacturing point of view, there will be innovative welding processes implemented, required to manufacture these heavier towers in a quick and competitive manner.
The market trend is going forward to bigger sizes on offshore wind turbines, so this is creating 2 issues. One is the logistic issue, and the second one is the manufacturing on those big complex structures to be fabricated in very short time. Navacell is providing a solution with low cost and low weight modules, and as well modules batch fabrication in parallel to mitigate the schedule risk.
Wind turbines are increasing their power capacity, so the bolting members also are increasing. So this makes a logistic problem. And ERECA in SEAPOWER project has developed 2 lines of investigation. One is to increase the mechanical properties of the bolts of the joining members. Another one is new designs of joints. So with these 2 ways, ERECA reduces these logistic problems and also gets bigger effort joint.
Bigger wind turbines will require bigger dynamic cables for inter-array connections at 66 kilovolts. Consequently, cable logistics, handling and connection operations will be longer and more complex than today. DITREL has developed one electrical pre-connector up to 66 kV that reduces the inter-array connection costs and time, and additionally allows the electrical disconnectability of the floating platform for critical maintenance operations.
The treatment developed as SEAPOWER project is an organic coating with less thickness than those commercially applied that manage to exceed the specification requested to an onshore coating. It can replace certain metallization treatment applied now in wind turbines, offering a more eco-sustainable and durable alternative. This coating has been tested in real-life conditions without showing any deterioration, offering a biofouling, corrosion and impact-resistant solution.
The focus has been on safety and reliability. The worst case scenario was considered and identified as being floating turbines. This led us to a rack and pinion solution. In addition, a strong mast has been designed, which is fixed to the internal platforms rather than to the tower walls. This will ease the installation and also give us a standard solution for all different types of turbines.
The strategic objectives of SEAPOWER project has been achieved with the creation of knowledge, new companies, patents, and specialized jobs. The technical results provide a set of innovative solutions, both in processes and in products, that address the challenges in increasing the power of offshore wind turbines. Further development will focus on a real-scale demonstration in sea conditions and the operation and maintenance of the offshore wind farms.